Good afternoon, everyone. Welcome to the session for mathematics. Rather, if you remember, in our last session, we were doing determinant and matrices. We had solved some problems, and I'm not going to skip anything. I will be just continuing from that problem which I completed last time. So we are there with the application of properties of determinants. And I request everyone to have paper and pen, copy and pen with you, so that simultaneously you can see, you can write, you can understand what I'm saying. You can see my screen, the presentation is
Yes,
visible to you. Okay.
yes,
So if you remember, last time we did this problem. What I told you to do, it was rather to see what is required, what is has to be proved. What I did, I just kept an eye on the right hand side of the problem. There I can see that it is within brackets, it is written as x plus a plus b plus c. Going back to the problem that is on the left hand side, we can see that if we can add all the columns together, that means C1 can be converted as C1 plus C2 plus C3. So we are going to get same thing in the column. That means all the elements of column 1 will be same, so that it will be easier for us to take that common. I did that. After taking a common as x plus a plus b plus c, I will be left with 1 1 1 in column 1. Now, if you remember, I told you you have to make as many as elements as 0. What I will be doing, I will be operating row 2 and row 3. That means I will be subtracting row 1 2 from row 2. 1 minus 1 will be 0. And simultaneously, all the elements of the row will be converted. You can see over it what I did. Row 2 tends to row 2 minus row 1, and row 3 tends to row 3 minus row 1. After performing that operation, we are left with 1 BC, 0 x 0, 0 0 x. As maximum number of the elements are 0, what we can do, only the diagonal will be left. You will be multiplying x by x. That will be x squared, and you will be getting the answer within 4 steps. Now moving further. Again, this is somewhat complicated. Here you can see that there are 3 columns, 3 rows, and different terms. And keeping an eye on the right hand side, I can see that there is a number a plus b plus c, as well as product and square. Now what to do? First of all, the thing is that we have to operate either row or a column, one thing at a time. If I do, row 1 tends to row 1 plus row 2 plus row 3. So what I'm going to get? I will be getting 2a plus 2b plus 2c throughout the row, and I can take 2 common. So I will be left with a plus b plus c. I did the same thing. I took 2 times of a plus b plus c, and keeping going back to the problem on the right hand side of the equation, I can see that I have already achieved two numbers, two things. What were to be proved? Now, coming back to the problem, I'm having 1, 1, 1 in row 1. That means I have to convert these three ones into two zeros. So now what I will be doing, I will be operating column 2 and column 3 with column 1. That means column 1, or either you can do one thing, you can convert this also, or here I have converted column 1 and column 2. That means I will be subtracting column 1 or column 2. You can see that what I have done right now is column 1 tends to column 1 minus column 2. I will be getting 0 the first element. And secondly, I will be doing C2 minus C3. That means in that case, I will be getting 0 at column number 2. Now, once this has been achieved, what I will be doing, I will be opening with respect to this. Since I will be opening with respect to this, the sign will be plus, and this will be removed. This will be removed. I will be left with these four elements. And for these four elements, what I have to do? I have to multiply this with this, minus this and this. This is written over here. Open this bracket. Multiply C with B and A. So I will get BC minus AC and minus B square plus AB. And I will be opening this A minus A plus A minus B whole square. A minus B whole square is A square plus B square minus 2AB. So here in this case we have A minus C. So it will become A square plus C square minus 2AC. Now open all these. That means remove the signs. Since we are having minus over here, so the signs of all these will change. This will become minus A square, minus C square, and plus 2AC. You have plus 2AC and this minus 2AC, minus AC, so it will become plus AC. So you are left with AB plus BC plus AC minus A square minus B square minus C square. This is what your question was. Is that clear? What we have done? We have first of all made these elements at same, then we have taken this common, and then we have started the transformation of converting or making the maximum number of elements as 0. Here we have made this. Moving further to the next problem. Now you can see over here what's happening. Using the properties of determinant, you have to prove this. Now see what is happening. Here we have this. And going back to the problem, we can see that if we can add columns or rows, we are getting the same element in one of the row or one of the column. So what I have done, I have taken C1 tends to C1 plus C2 plus C3. 2x plus 2x, 4x, 4x plus x, 5x, plus 4 will remain same. Again adding 2x plus x, 3x, 3x plus 2x is 5x, 5x plus 4. And again, this will be 5x plus 4. Here this is from all the other elements will remain same. Take this common out, you are left with this. Now make this 0, this or this 0. I've made row 2 and row 3 as 0. This element will become 0 because I have to subtract. R2 tends to R2 minus R1 and R3 tends to R3 minus R1 or R2 as required. We are going to get this part. Again, you can see we have made 3 elements as 0. So we will be solving this part only because this will be 0. That means we are left with minus and minus plus. X minus 4 into x minus 4 is x minus 4 whole square. Okay, this is what was required. Is that clear? We had been doing the same thing again and again. But here we have to see either we have to take column or we have to take row. And after taking that, this row and column is taken to make or to convert either a row or a column as one, and then trying to make maximum elements as 0. Here we have taken column and row. Is that clear?
Yeah.
Okay. Now we will see the applications of determinant in finding out the area of a triangle. If you remember, area of a triangle is half into base into height. That is in terms of solids or planes. Now we are having 3 coordinates of a triangle. That is x1, x2, x1, y1, x2, y2, and x3, y3. Now, if we have to find the area of this triangle, which is formed by joining these 3 points. So here what we are supposed to do, this is the standard formula. Delta is equal to 1 by 2, determinant x1, y1, 1. In the third column, it will be 1. It has to be converted into a 3 by 3 matrix. So it will become x1, y1, 1, x2, y2, 1, x3, y3, 1. As per the norms, you have to open it. And after opening it, or that means after solving this, you will get this. x1, now how to remember it? There are 3 numbers, 1, 2, 3. If we are taking x1, so y will be 2, 3. y2 minus y3 plus x2. 2 is there, so 3 and 1 will come. Y in terms of 3 and 1. Plus now x3 comes, so y will be 1 and 2, the same order. Don't change the order. This is obtained by opening this only. This is the formula what you have to remember for finding out the area of a triangle if 3 vertices of the triangle are given to you. How to remember it? 1 by 2. You will first start taking with x1 and you will be taking y2 minus y3. Then plus x2, y3 minus y1. And then plus x3 into y1 minus y2. There is one condition. If I say these 3 points are collinear. Collinear means all these 3 points lie on a straight line. That means the area of a triangle will be equal to 0. Because then in that case, no triangle will be formed. Since all the 3 points are on a line or in a line, the triangle cannot be formed. In that case, this area will be equal to 0. And what will happen? These components, you have to leave 1 by 2. This component will become, that means area will become 0. We'll see to it how it comes. First of all, we will find out the area of a triangle whose 3 vertices are -1, 8, 2, -2, -3, and 3, 2. You can see how it is being solved. If you remember, this is the same step. First of all, what we have to do, this is the standard result. We will be replacing x1, y1 by these numbers, -1, 8, 1, -2, -3, 1, 3, 2, 1. Again, next step will be 1 by 2, bracket, take this number -1, multiplied by -3 into 1, that will be -3, -2 into 1, it will be -2. Close the bracket. Thank you. -8, first one is plus, second one is minus. +8, this will become -8, bracket, remove this. You will be left with -2, 1, 3, 1. -2 into 1 is -2, and then it will become -3. +1, third one, -2 into 2 is -4, minus into minus will be plus, 3 into 3 will be 9. Simplify it. You will get 50 by 2. 50 by 2 is 25. Don't forget to write square units because area is always in square units. Is that clear?
Yes, that's clear.
Okay. Now comes condition of collinearity of 3 points. That is what I told you earlier. If the 3 points are collinear, that means they are on the straight line. Then mathematically or technically, the area of the triangle so formed will be equal to 0. The matrix form you can see 1 by 2 into the coordinate, 1 by 2 times the coordinate of the triangles. 1 by 2 will be removed. You will be left with this. Now, what will be the nature of the question? 3 points will be given to you and you will be asked to find out a coordinate so that the area of the triangle is 0 or the 3 points are collinear. Now see to the problem. If the points x -2, 5, 2, 8, 8 are collinear, you have to find x. And the condition is using determinants. Do you remember the formula x -2, 1, 5, 2, 1, 8, 8, 1. Solve it and it has to be written equal to 0. Open it up in terms of x. X into 2 minus 8. -2 will become +2 into 5 minus 8 plus 1, 40 minus 60 equal to 0. Remember, x can be a negative number or a positive number. Don't be worried about it. But your calculation has to be correct. Opening up, you will get -6x minus 6 plus 24. That will be 6x is equal to 18. Take that side. Minus sign will be removed. You will be left with x equal to 3. That means your answer is x is equal to 3. Condition is all these 3 points are collinear. If the points are collinear, area of the triangle will be equal to 3. Now, we have to solve a set of equations. Now you can see there are two equations, a1x plus b1y equal to c1. The second equation is a2x plus b2y equal to c2. We have to determine the value of x and y. But remember one thing, this can only be done when t is not equal to 0. Now your question arises, what is t? T is this matrix, the coefficient of the two equations. That means the coefficients of two variables in the same order. Don't change the order. I'm again and again telling you the same thing. Don't change the order of the equation when you are taking up the coefficients from the equation. A1, A2, B1, B2. When you will solve it, it will become A1, B2 minus B1, A2. Remember, it should not be equal to 0. And when you are finding out D1, replace this X by C1, C2. Here it comes. And for D2, replace Y, this 5, B1, B2 by C1, C2. These are the three matrices. You have to find the value of these three matrices. And for X, it will be D1 by D. And for Y, it will be D2 by D. Is that clear?
Yes, sir.
Now see to the problem. This is known as Cramer's rule. We have to apply Cramer's rule to solve the equation. This is 2x minus 3y equal to 7. 3x plus y equal to 5. I cannot change the order, so it will be 2, 3 and minus 3, 1. It will be like this. Solve it. 2 plus 9 will be 11. D is not equal to 0. We can move further. D1 is replace this 2, 3 by 7 and 5. Replaced. 5 plus 15. It becomes 22. And D2, replace this y by 7, 5. Replace. 5 to the 10 minus 21 becomes minus 11. D is not equal to 0. We will apply Cramer's rule. X is equal to D1 by D. 22 by 11 is 2. Y is equal to D2 by D is equal to minus 11 by 11, that is minus 1. Now the question arises. The value of X and Y we have found is correct or incorrect. What will you do? Just replace, put X equal to 2 and Y equal to minus 1 in this equation. See, you are getting 7 or not. Or you can put it in the second equation. Values of X and Y in this equation on the left hand side and see whether you are getting the right hand side or not. Just let me know. In any of the equation, you can keep the value of X and 2. This is X and Y. This is basically required what I'm asking you to do it, because whatever the values of X and Y you have found is correct or not. If they are correct, they will be satisfying the equation. Anyone who has completed this? This is true for both the equation or one equation. This is true for both the equation or a single equation. I don't know how much time it takes. Just put it in the second equation. 3 into 2 is 6.
Yes, sir, it's true.
6 minus 1 is 5. Okay. Now I will be using Cramer's rule for 3 equations. That means 3 equations, 3 variables. Equations are in front of you. 5x minus y plus 4z equal to 5. 2x plus 3y plus 5z equal to 2. 5x minus 2y plus 6z equal to minus 1. We have 3 equations and 3 variables. Take out the coefficients in the same order in which the equations are given to you. After taking up the coefficients of x, y, z, in the order it is given to us, we get 5 minus 1, 4, 2, 3, 5, 5 minus 2, 6. We have to calculate the value of D. It will be calculated as, open it, it will be 5 into 18 plus 10. First one is plus, second one is minus, minus into minus is plus. It will become plus 1 into 12 minus 25 plus 4 times minus 4 minus 15. On solving, you will get 140 minus 13 minus 76, which comes out to be 140 minus 89. That means you are left with 51. And 51 is not equal to 0. That means we can move further. Now, in moving further, what we have to do? Replace the coefficients of x, these coefficients, by these numbers. These coefficients by these numbers. That means 5, 2, minus 1. This has been replaced by 5, 2, minus 1. Rest all the elements will remain same, in same order. Don't change the order. Open it up. 5 into 18 plus 10. Again minus 1 is there, so it will become plus 1. Plus 1 into 12 plus 7. Third one is plus 4, and it will be minus 4 plus 3. On solving, you will get 153. Is that clear?
Yes, sir. Is that clear?
In D2, what I will be doing? I will be changing the coefficients of y with the constants. You can see I've changed by 5 to minus 1. Open it up. 5 into 12 plus 5. Minus 5 into 12 minus 25. Plus 4 into minus 2 minus 10. You will get, after solving, you will get 150 minus 48. That comes out to be 102. Similarly, for D3, we will be replacing the coefficients of z by 5 to minus 1. That means now we will be changing this one. This is what we have got after replacing. Now opening up, 5 into minus 3 plus 4. Now it is minus 1, so it will become plus 1. Plus 1 into minus 2 minus 10. Okay. Third one will be plus 5. Plus 5 into minus 4 minus 15. That comes out to be 5 minus 107. It is minus 102. We have got all the 4 values. That means x is equal to d1 by d, 153 by 51, which comes out to 3. d2, y is equal to d2 by d, that is 102 by 51. That comes out to be 2. And z, d3 by d, which is minus 102 by 51. That is equal to minus 2. Now you have 3 values. Value of x as 3, y as 2, and z as minus 2. I don't know whether this is correct or not. Place these values in either of the 3 equations and see whether that is correct or not. I'm showing this answer again. You have the value of x is equal to 3, y is equal to 2, and z equal to minus 2. Put up in any of these equations, any of these 3 equations. Has anybody checked it? I'm showing this again. X is equal to 3, Y is equal to 2, and Z is equal to minus 2. X is equal to 3,
Uh,
Y
Not correct.
not correct.
The 5x minus y. Um, the answer first 0 and minus 2 and minus 1.
Madam, just let me know. Where is the value of 4Z? You have three values. X is equal to 3, Y is equal to 2, and Z equal to minus 2. 5 into 3 is 15. 15 minus 2 is 13, and 13 minus 8 is 5. You have three variables, three values have been found out. That is the correct way of checking it whether what you have calculated is correct or not. Okay, so I hope this is clear. Now, matrices. Thank you. A matrix, we have seen everything now we have seen. As per what we have, sometimes I've used a shortcut. Now it will be an elaborate awareness of the concept. A matrix is a rectangular array of numbers. There are many situations in mathematics and science which can deal with the rectangular arrays of numbers. For example, the following table gives vitamin content of three foods in conventionally chosen units. Food 1 consists of three vitamins: vitamin A, vitamin C, and vitamin D. Similarly, food 2 has the contents and food 3 has the content. Now, this information can be converted into a rectangular array which comprises of rows and columns. Same order. Now let's see, we cannot change the order. Order will remain same. Since we have three columns and three rows, that means it will be a 3 by 3 matrix. Order of 3 by 3. Remember, number of rows comes first. R comes first. There are three rows. Rows are horizontal and columns are vertical. These are the columns and these are the rows. These are the rows and these are the columns. Row, number of rows come first. This is general representation. It can be represented, there can be n number of elements. If you remember, I have told you that the elements are denoted by Aij. I is for the row and J is for the column. You can see A11. A11 means first element of the first row and the first column. If you talk about A33 or A23, A23 means the element of second row and third column. This matrix can be placed up in two vertical lines, two close brackets, or that is what conventionally it is used, two close brackets or two vertical lines. Elements are Aij. As I told you, first the row will come, then the column will come. And the order of the matrix in the above matrix can be m rows and n columns. Because the thing is fixed in this particular problem, what we are seeing. That means rows. I told you number of rows will come first and number of columns will come later. And it is represented by m cross n. M cross N. M means the number of rows and N means number of columns. That means number of rows cross number of columns. Now see, horizontal ones are the rows and the vertical ones are the column, and the element is denoted by M, A, and J. M here is the rows and J is the column. That doesn't make any difference if you represent by Aij. Concept will remain the same. Order of the matrix. Anyone who can tell me the order of matrix A?
Sir, the order of matrix A 2 cross T.
Why?
Um, because matrix A has 2 rows and 3 columns.
Thank you. The third one.
The third one, 3 cross 2, because matrix B has 3 rows and 2 columns, and matrix C 3 cross or into 3 because it has 3 columns and 3 rows.
Thank you. Correct. Now the thing is that the concept application comes. A matrix has 16 elements. What is the possible number of columns it can have? A matrix is in the form of a mat. It can be of any form. The question is, if it has 16 elements, what are the possible orders of the matrix? Anyone who can see, I've written the answers over there. But any one of you who can think of why these answers are written in this form. I'm talking about the number of elements, and we want possible numbers of columns.
Teacher, because the multiply of row and column should be the total of elements. And first example, we can see one when one multiplies 16 is 16. It is total of the elements the matrix will have. And the
Yes,
second example also, 2 multiply 8, its total will be 16 again. And the third example, for 4 multiply 4, its total will be 16. For these reasons, it has the possible order of 1 multiply 16, 2 multiply 8, 4 multiply 4, 8 multiply 2, and 16 multiply 1.
absolutely correct. But now we have to complete the answer. How many number of possible columns are there? As I told you, n by n means first row will come and the second number will be the column.
And the first character is 1 is row matrix. Yeah.
What we can form? What we can form if 16 elements are there. Is that correct to everyone? Or somebody has different opinion about it?
So if we have 16 elements in a matrix, so it might have 8 columns and 8 rows to
Huh?
have or
8 by
if
8.
we have
8 by 8 means 64 elements, madam.
no, if we have 16 elements in a matrix, so we might have 2 columns or 8 rows or 8 columns or 2 rows.
Yes, it is there. Absolutely correct. Is that clear to all? Now, you have to form a matrix or write a matrix by the given rule. You have Aij equal to 1 by 3 minus I plus 1 by 4 minus j. And you have to form a matrix of order 2 by 3. 2 by 3 means there will be 6 elements. Okay. I'm doing so many things simultaneously. 2 by 3 means there are how the answer will be solved. 2 by 3 means there will be 6 elements. 2 by 3 means there will be 2 rows and 3 columns. Okay. Now, if I pick up the problem A11, A11 will means that I will be replacing I by 1 and j by 1. Is that clear? Write up the values of I and j in this, and you will get 5 by 6. Similarly, 1, 2. Because you said there will be 2 rows and 3 columns. That means you have to calculate A11, A12, A13, A21, A22, and A23. That's it. Replacing I by 1 and j by 2. You will get 1. Similarly, you will be doing for this and for the rest of these elements. Now, what is the way of writing them? As the order says, you have to write this in the same order over here. These are the elements of the row. These are the elements of the row. And these are the elements of the column. Because you have 2 rows and 3 columns. The solution is in,
Sir, I have a question.
yeah.
Why I can take 1, 2?
Why I will take 1, 2? Because you are finding out the elements of the matrix. And
And J can take 1, 2, 3.
A and Aij means first element, first row. I can take these possible values of I as 1 and 2, and for j I have to take 1, 2, 3 because we have to form a 2 by 3 matrix. It will have 6 elements. 2 by 3 matrix means it will be having 2 rows and 3 columns. Is this clear now? Okay, so your answer will be 5 by 6, 1, 3 by 2, 4 by 3, 3 by 2, and 2. The question was the element in the general form was given to you. You were found or asked to calculate or to find a 2 by 3 matrix which means it will be having 2 rows and 3 columns. Now, what are the different types of matrices? You can see here in the first one, it is a row matrix because only a single row is there. On the right side, you can see that is a column matrix because all the elements are in the form of a column only. Third one is zero matrix as all the elements are zero. And square matrix is a matrix in which number of rows and number of columns are same. Here we have 3 rows and 3 columns. That means it will be a 3 by 3 matrix, a form of square matrix. Next one is diagonal matrix. Diagonal matrix is that matrix in which all the elements are in diagonal form. Rest remaining all the elements are 0. Your diagonal elements are 3, -4, and 4. And remaining all other elements are 0. Then comes your scalar matrix. A scalar matrix is a matrix in which the diagonals can be a number or are a number and remaining other elements are 0. And if you remove this 6 by 1, in that case the diagonal elements will be 1, and if diagonal is 1 and remaining all other elements are 0, it will be an identity matrix. You can see it how it is written. And you have to denote that by I3. I3 means 3 rows and 3 columns. That means a matrix of 3 by 3. What is meant by equality of matrix? If we talk about equality of matrix, that means we can say that we are talking about 2 matrices. And they are separated by a sign of equal to. How, under what conditions the 2 matrices will be equal? 2 matrices can be equal only in that condition when both the matrices are of the same order. You have to remember that 2 matrices will be equal only and only if they are of same order. Both the matrices are of the same order. If you take this example, what is given to us here, A, B, C, D is equal to 1, -2, -3, 4. And we are to calculate the value of A, B, C, and D. What we will be doing? The first matrix on the left hand side has 2 rows and 2 columns. That means it will be a 2 by 2 matrix. And on the right hand side, again we have 2 matrices, 2 rows and 2 columns. That means it is of 2 by 2 order. If both the matrices are of the same order, they can be equated. If they can be equated, then each element, respective element, will be same. What is meant by that? That means A will be equal to 1, B will be equal to -2, C will be equal to -3, and D will be equal to 4. 2 matrices are equal only and only if they are of the same order. This is the condition. They can be subtracted even. Here comes the order addition of matrices. Again the same thing. 2 matrices can be added up only and only if they are of the same order. That means, what is meant by order? Order means the number of rows and number of columns will be same in both the matrices. If we take up an example, A is equal to 1, 3, 4, 2, 3, 4, -3, 4, -5. and B is 2, 3, 1, 5, 4, 2, 1 minus 4, 3. You are asked to calculate A plus B. For A plus B, you have to first of all see that what is the order of these two matrices. Matrix A has 3 rows, 3 columns. That means it is a 3 by 3 matrix. And matrix B again has 3 rows and 3 columns. That means it is a 3 by 3 matrix. First condition for addition is that they should be of the same order. That means here order is 3 by 3. These can be added up. Now how the addition is done. Respective element of both the matrices will be added up. That means 1 plus 2, 3 plus 3, 4 plus 1. I'm writing the elements by adding the row elements. 1 plus 2, 3 plus 3, 4 plus 1. They have to be written in the same order in front of that row only. 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 2 is 6. Minus 1 plus 1. Minus 3 plus 1 is minus 2. Minus 4, 4 minus 4 is 0. And minus 5 plus 3 is minus 2. If you are adding a 3 by 3 matrix, that means a 3 by 3 matrix to a 3 by 3 matrix, your answer will be same. That means your answer will be a 3 by 3 matrix. Now, this is something very interesting. Multiplication of two matrices. First of all, we will start with multiplying a matrix with a scalar number. If you remember, while we were solving problems related to determinant, what we did, we multiplied a particular row or a particular column by an element. In that case, what was happening? All that elements of that particular matrix or determinant were multiplied by the same number. Scalar means a number. And if you are multiplying a number with a matrix, the order will remain the same because that number is only multiplied to respective elements of the row or to the column. Now you can see our problem is here. A is equal to 1, 3, 4, 1, 2, 3, minus 1, 1, 1. You can see that we have 3 rows and 3 columns. That means its order is 3 by 3. We have to multiply by 2. That means your problem will become 2a. 2a means every element of the matrix has to be multiplied by 2. 2 into 1 is 2, 2 into 3 is 6, 2 into 4 is 8, 2 into 1 is 2, 2 into 2, 4, 2 into 3, 6, 2 into minus 1, minus 2, 2 into 1, 2, 2 into 1, 2. Your answer will be a 3 by 3 matrix. Its order is not going to change. The order of the matrix does not change if a matrix is multiplied by a scalar quantity. What are the properties of addition? I told you addition is only possible if we have matrices of same order. If matrices are to be of same order, then it's correct. It can be A plus B, which will be equal to B plus A. That is commutativity. If we talk about associativity, it will be A plus B plus C, which will be similar to A plus B plus C. If you multiply matrix by M or N. So what you will be doing? You will be multiplying, adding A plus B, and you will be multiplying by a matrix. Will be equal to MA plus NB. If you are multiplying with M plus N, then it will be equal to MA plus NA. But the concept is not going to change. We will see how this works. You have to find the X. Now see very carefully what I am doing. I will be doing so many operations in a particular problem. You have to find X. If your Y is a matrix of 2 by 2, well, that means Y is equal to 3, 2, 1, 4. And the condition for finding out X is 2X plus Y equal to this matrix. Minus 1, 0, minus 3, 2. Go back to the basics. Multiply, first of all, you have the matrix of Y and you don't have the matrix of X. What I did, 2X plus, replace Y with the matrix. That is 2X plus 3, 2, 1, 4, which is equal to minus 1, 0, minus 3, 2. Same method has to be followed, what we normally do in finding out the values of the variable. So I will keep 2x on the left hand side. We have equal to sign in between, and I will be just transferring matrix y on the right hand side. When I will be moving the matrix y on the right hand side, I have to change the sign. You can see that a minus sign is in between the two matrices. Now, order is same, matrix, and elements can be subtracted. So minus 1, minus 3 is minus 4. 0 minus 2 is minus 2. Minus 3 minus 1 is minus 4. And 2 minus 4 is minus 2. You will get I will just bring this 2 on this side. So it will become 1 by 2. 1 by 2 of this. Multiply each element by 2. You will get minus 2, minus 1, minus 2, minus 1. This is your matrix. Since the problem is related to matrix, your answer will be a matrix. What will be your answer? It will be a 2 by 2 matrix. And 2 by 2 matrix is a square matrix because it has 2 rows, 2 columns. In this particular problem, you saw how subtraction is done, how multiplication is done, and how a matrix is obtained. Is that clear?
Yes, sir, that's good.
Now see, find a matrix C such that A plus B plus C is a zero matrix. That means you have a value of A and B. Your given condition is A plus B plus C equal to 0. And what I will be doing? I will be just replacing A and B with the matrix. So it will become 2, 0, 1, 3 minus 1, 0, plus 2, 1 minus 1, and 0, 2, 1, which will be equal to plus C, which will be equal to 0. 0 means a zero matrix of same order. Remember, subtraction and addition is only made when the order of the matrices are same. After calculating what it will become, 2 plus 2 is 4, 0 plus 1 is 1, 1 plus 1, 1 minus 1 is 0. Next row will be 3, 1, 1. You can see that it will become a 2 by 2 plus C equal to 0. Now you have to determine the value of C. So keep C on the left hand side and move this matrix to the right hand side. When you will be transforming this matrix to the right hand side, its signs will change. And when the signs change, what it will become? C equal to minus 4, minus 1, 0, minus 3, minus 1, minus 1. This is the answer C. You can see that the order of matrix C is same as that of the matrix of order of order of A and B. What is the order of matrix C? Anyone?
The order of matrix C is 2 into 3 because the order of matrix A and B is 2 into 3 and
Madam,
all
I
these
just
are
want to
same.
rectify one thing. It's not 2 into 3. It is 2 cross 3. 2 into 3 makes any, it can be interpreted in any form. 2 cross 3. Or 2 by 3. That doesn't make any difference. Don't say 2 multiplied 3 or any other term. It should be 2 cross 3 or 2 by 3. The order of C is 2 by 3 because the order of A and B is 2 by 3 and order of as the order of A and B is 2 by 3. The order of C will also be 2 by 3. Correct? Multiplication of matrices. This is somewhat confusing. Many of you are going to make a mistake or have been making mistake, but right now I don't want that you should make any mistake in future if it is related to multiplication of matrices. You might have seen an alphabet, a number as 7. Every one of you is aware about the number 7. We will see how this 7 works over here in case of multiplication. Now, actually, there are some basics. A matrix can be multiplied by a scalar or can be multiplied by any matrix of any order. As far as your addition and subtraction is concerned, both the matrices have to be of the same order. But in case of multiplication, it's not necessary that the order should be of the same order. Then what? The question arises, then what? If that is the question, it has again a very simple answer to it. You have to see that if you are multiplying two matrices, the number of columns in the left hand matrix must be equal to number of rows in the right hand column or right hand matrix. Can anyone tell me what is the order of matrix A?
It's 2 by 3.
And what is the order of matrix? B?
3 by 1.
Can anyone tell me what will be the answer of this matrix?
The answer should be 2 by 1.
How it can be 2 by 1?
Because the order of A is 2 by 3, and from B is 3 by 1. When we want to multiply these matrices, the column of matrix A is equal with B, then the column A is 2, and the row of B is 1, and the answer will be 2 by 1.
That means you mean to say that what you are seeing in the presentation is incorrect. Now I tell you how it is performed. Each element of left hand corner will be multiplied by each element of the second matrix. That means 1 into 3 plus 2 into 1 plus 2 into 4. That will be your first row. And your second row will be 2 into 3 plus minus 1 into 1 plus 4 into 4. That means this will come out to be 13 and 21. That means there are 2 rows and 1 column. This is how multiplication is done. Now remember one thing, how this is done. Always make 7 at this form of things. This by this. These elements will be multiplied by these elements all together. All together. Again, this and this. I will show you with another problem. First, try to understand what is depicted over here. These numbers are multiplied in this order, moving left to right and coming down. 2 into 3 plus 2 into 1 plus 2 into 4. The second row will be multiplied, each element of the second row will be multiplied by each element of the column of row 2, the matrix 2. That will be 2 into 3 plus minus 1 into 1 plus 4 into 4. Now, what are the properties of, I said it's somewhat difficult, but you have to do more practice for the multiplication of the matrix. If you say that there are 3 matrices, A, B, and C. A when A is multiplied by the product of B and C will be similar as the product of A and B and then C. That is the associativity. And in multiplication, this multiplication is distributive over addition. So here, when you are adding, if when you are multiplying the sum of B and C with A, you will get AB plus AC. And if you are multiplying the sum of A and B with C, you will get AC plus BC. The answer will remain the same. There will be no change as such. Now, here you can see that there are three matrices of different order, and in between element is not available to us. That is, it has been replaced by X, and you are being asked to calculate the value of this X. Now, see to the problem what I've done. We have one row, three columns, and in the second matrix, we have three rows, three columns, and in the third matrix, we have three rows, one column. To make it simpler and easier, what we will be doing? We will be first multiplying first and second because it has three rows. The first one has one row and the other one has having three columns. Order number is same, we can multiply. Now how we will multiply? That means each element of first matrix will be multiplied by each element of the second matrix in the column form coming from top to bottom. That means 1 into 1 plus 2 into 2 plus 1 into 1. Second element will be 1 into 2 plus 2 into 0 plus 1 into 0. And the third element will be 1 into 0 plus 2 into 1 plus 1 into 2. And the third matrix will remain as it is. On solving, you will get 6, 2, and 4. Here, what is happening? 1 by 3 is being multiplied by 3 by 1. Your answer will be 1 only. You can see, multiply by 6 into 0 plus 2 into 4, 2 into 2 plus 4 into x. It becomes 4 plus 4x. That is 4x is equal to minus 4. X is equal to minus 1. See to this problem very carefully. What I've done, I multiplied this by this. Second will be this by this. Third will be this by this. And these elements are written over here. And the answer is written in this form, 6 to 4. This is 1 by 3 matrix. 1 by 3 matrix is being multiplied by 3 by 1 matrix. Your answer will be 1 by 1. That means only an element. You've seen it, the element is 4x. Now, another problem is there. If A is this matrix and identity I is the matrix, keep one thing in mind. If only I is written, you have to assume I as of the same order as A or B or C, whatever is the problem is, you have to take the same order. Since your A is a 2 by 2 matrix, I will be a 2 by 2 identity matrix. That means identity matrix is a matrix in which diagonal element is 1 and remaining all other elements are 0. Now you have to find K. if a square is equal to k minus 2i. Okay, so first of all calculate a square. A square is what? A 2 by 2 matrix. So when you are multiplying a 2 by 2 matrix by a 2 by 2 matrix, its answer will be a 2 by 2 matrix. Now, how? 3 into 3, 9. 9 minus 8, first element. Second will be 3 into minus 2, minus 6. Minus 6 plus 4. Minus 6 plus 4. Third one, 4 into 3, 12. 12 minus 8. Here comes 4 into minus 2, minus 8. Minus 8 or minus 8 plus 4. Here. You will get 1 minus 2, 4, 4. It is a 2 by 2 matrix. Go back. A. Multiply k with every element of A. It will become 3k minus 2k, 4k minus 2k. Go back to this problem. Write all the values. This is a square is equal to k times of A. You have already calculated minus 2 into identity matrix. This has been calculated. Now, what has to be done? Multiply this 2 by every element and then subtract it. It will become 3k minus 2. Minus 2k. If the order is same, two matrices will be equal. That means for two matrices to be equal, each element of the first matrix will be equal to each element of the other matrix. That means there is no value as 0. So we can pick up any value. Any term it can be taken. Pick up any value. You can take any other element and let me know the value of k. And which element you have taken. And how you got it 1. Any one of you. I have compared these matrices because the equal sign is there, and on the left hand side as well as on the right hand side. The matrices are of the same order. Comparing can only be done if the order is same. Anyone? What I've done?
Sir, when two matrices have the same order, we can say that all these two matrices are equal with each other. And when two matrices are equal with each other, every element are equal. For example, 2k, 3k minus 2 equal to 1. 3k equal to 1 plus 2, 3k equal to 3, k equal to 1, and minus 2 equal to minus 2k, and k equal to 1, and 3 equal to 4k, 4 equal to 4k, k equal to 1, and minus 4 equal to minus 2k minus 2, and minus 2k equal to minus 4
Correct,
plus
correct.
2. And
Correct, Mother.
yeah, yeah.
Correct. Thanks for explaining the. It's very simple, very clear. We don't have to go that much. It's very good that you have understood it correctly. The concepts are good. The thing is that If we have to do it once only, if two matrices are of same order and equal to sign is there, it is theoretically every element in the two matrices will be similar or will be equal. I have taken it in this particular solution, I have taken the first element. It is 1 equal to 3k minus 2. If I am going to pick that minus 2 on the other side, it will become 3. 3 will be equal to 3k, k will be equal to 1. Make it simpler. Pick up the second element. Minus 2 is equal to minus 2k. Minus 2 got cancelled, k is equal to 1. Simple. Or simple. 4 is equal to 4k, k is equal to 1. You will get the same answer. This is what you explained.
Yes, sir.
Okay. Now, we have to do different operations. You have to show that A is equal to this. Satisfies the equation A squared minus 12A plus I equal to 0. Can anyone tell me what will be the order of I in this particular problem?
The order of I will be 2 by 2 because the A is also 2 by 2.
Anyone else?
And the reason is this, which when identity matrix will be in another order, we can't subtraction or addition in this matrices.
That's correct. Order will be the same. It will be a 2 by 2 matrix because when we are adding or subtracting, the order cannot change. Order will remain same. So as far as this
Yes, sir.
part is concerned, it will be a 2 by 2 matrix and it will be of the form 1001. Now going back to the problem, I have to first of all solve A square. A square means these matrix has to be multiplied by itself. So the first element will be 6 into 6 plus 5 into 7, that is 35. Second element will be 6 into 5 plus 6 into 5, 30 plus 30, that is 60. Third element will be 7 into 6 plus 7, 6 into 7, 42 plus 42, that will be 84. And the fourth element will be 35 plus 36, that is 71. After multiplying, you are getting an odd matrix of 2 by 2 order. Now, going back to the question, that is A square minus 12A plus I. Now I will be writing everything in the same order in which the question has been asked to us. It will be 71, 60, 84, 71. That is the value of A square minus 12 of A minus 12 A type of A type plus identity matrix of order 2 by 2, that is 1001. You have to multiply each element of a matrix by 12. It will become 6 into 12 is 72, 6 into 12 is 50, 5 into 12 is 50, 60, sorry, 12 into 7 is 84, and 12 into 6 is 72. Now, pick up and solve it. Here you can see the order is of 2 by 2. Every matrix is of the order 2 by 2. Got it? Or anyone has any doubt in it? The solution is here. If you have any doubt, just let me know. But this is the exact way in which the problem has to be solved. While you are solving mathematics, a particular order has to be followed, and the order is here. It will be better if you follow this order. Is this clear?
Yes, sir.
Okay. Does anybody have any doubt in the process and procedure?
No, sir.
Okay. Moving further. Now transpose of a matrix. Transpose of a matrix is basically transforming or changing rows into columns. And this transformation is denoted by a power t or a dash. You can see a power t or a dash. Matrix is A. A transpose is denoted by a power t or a dash. Now what we do? A matrix is in the form of A, B, C, D. What we have done it, we have converted the row into column. That means this AB has been converted into this form. As this has been brought this, so this will come over here. Not going to overlap. This will come over here and this will go over there. This is what we call it as transpose. The rows of a matrix are changed into the column in the another matrix. Now see to it. Your A is 5 minus 1, 6, 7, and B is 2, 1, 3, 4. You have to verify that A plus B transpose is equal to A transpose plus B transpose. So first of all, what we are supposed to do, we have to add A plus B. You can see how A plus B is added. So A plus B will be 7, 0, 9, 11. It transpose will be 7, 0, 9, 11. Okay. A transpose. Now going back to the problem. A transpose means you will be changing. A transpose will be 5, 6, minus 1, 7. And B transpose will be 2, 3, 1, 4. Add these to A transpose plus B transpose. You will get 7, 9, 0, 11. Both are true. Both are same. That means A plus B transpose is equal to A transpose plus B transpose. Is that clear?
Yes, sir.
Now, order is different. What we are supposed to find? We have been provided by two matrices, A and B. Now see, the order is different. The first one is of order 2 by 3. The second one is of order 3 by 2. That means its answer will be a 2 by 2 matrix. First of all, we have to find AB. We have to multiply these two matrices. Multiplication is same. 2 into 3 plus 4 into minus 1 plus minus 1 into 2. And the second column will be 2 into 4 plus 4 into 2 plus 1 into minus 1. The second row will be minus 3 into 1 plus 0 into minus 1 plus 2 into 2. And the second row, second column will be minus 1 into 4 plus 0 into 2 plus 2 into 1. You will get a 2 by 2 matrix. That will be 0, 15, 1, minus 2. This is AB. And what was asked? AB transpose. Just convert row into column. It will become 0, 1, 15, minus 2. Correct?
Yes, sir.
Now, just solve this. Can anyone of you can explain me what has been performed over here? You can see that it is a multiplication of three matrices with different conditions, and you are to find an element x which is missing, and that x has to be found when we have to follow these conditions. First one is a 1 by 3 matrix, second one is a 3 by 3 matrix, and the third one is again a 1 by 3 matrix. And keep an keep an eye on that thing. In the third matrix, at the top it is written transpose. So first of all, what we will do, we will start from left. Multiply first matrix by second one. Your answer will be a 1 by 3 matrix. 2x plus 4 minus 2. Your second will be x minus 2. And the third one will be minus x minus 4. After clubbing it, you will get 2x plus 2 and x minus 2, x minus 4. It has to be multiplied by x4 minus 1 transpose. Transpose it. The next step, transpose it. It is in the row form. You will get in the column form. It will be x4 minus 1. And then the left hand side you have a 1 by 3 matrix. This is a 3 by 1 matrix. Your answer will be a 1 by 1 matrix. After that, you will get 2x square plus 2x plus 4x minus 8 plus x plus 4 equal to 0. Club these numbers. This is a quadratic equation. 2x square plus 7x plus 2x square plus 7x minus 4 equal to 0. Are you aware of how a quadratic equation is solved?
Yes, sir, we know.
Oh, that's fine. Then it is fine. You can see, otherwise it would have become very tedious for me to explain. Here the equation is 2x square plus 7x minus 4. In brief, I will let you know what you are supposed to do. We normally follow, for a quadratic equation, a method which is known as splitting of middle term. Here what I will be doing, I will be splitting the product of 2 and 4, numbers only, not of the sign. 8, I will be converting the factors of 8 in such a way that I get 7. The factors of 8 are 8 into 1, 1 into 8, 4 into 2, or 2 into 4. Correct? I want 8. If I want 8, so I want 7. If I want to have 7, so I have to use 1 and 8. 1 and 8 can be, how 1 and 8 can be written as 7, equal to 7. How 1 and 8 can be written as either the product, either the sum or subtraction must be equal to 7. It can be written as 8 minus 1. 8 minus 1 is 7. And the factors are 8 and 1. After clubbing it, I will be getting 2x minus 1 into x plus 4 equal to 0. I will be getting two values because it was a quadratic equation. So I will be getting two values of x, which will be satisfying this condition, this equation. X is equal to minus 1 by 2 and x is equal to minus 4. These are the two values of x, which has been found after splitting of the middle term. Is that clear?
Yes, sir.
Then comes symmetric and skew-symmetric matrix. As you are aware of transpose, so we will be using the properties of transpose. A square matrix A is called symmetric matrix if, remember the condition, you have to remember the condition only. If A transpose is equal to A, this is called symmetric. And what will happen in case of a skew symmetric? A transpose will be equal to minus of A. Now, the question arises what we will do. Why we are doing it? We are doing it because we can perform an operation. That is, a square matrix can be expressed as a sum of symmetric and skew-symmetric matrix. That means A is equal to A plus transpose by 2 plus A minus A transpose by 2, where your A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetry. Okay, now question arises, what has to be done? This has to be shown. We have to show that this matrix is a skew symmetric matrix. What is the condition for skew symmetric matrix? That means for skew symmetric, A transpose must be equal to minus A. Okay, let it be like that. See to it, transform it. The original matrix is at the top. Your transform matrix will be 0, 5, 3, minus 5, 0, 8, and minus 3, minus 8, 0. Take minus common from all the signs. What will you get? Or you can see that it is in the form of minus A. If A transpose is equal to minus A, it is a skew symmetric matrix. Correct? Now, express the matrix A as the sum of symmetric and skew symmetric matrix. Okay, fine. It's very interesting to see. I will show you whether I can show you whether the solution what you have done is correct or not. Your A matrix is the original parent matrix what was given to you in the problem. A transpose will be, you will be transforming the rows into column. After transforming the row into column, you found this. Now, let P be equal to 1 by 2 A plus A transpose. Take 1 by 2. Your addition is possible only when you have a matrix of same order. You have the matrix of same order, nothing to worry, add up. You will get this. That means your P is equal to 1 by 2 times of this matrix. This is A plus A transpose by 2. Now, for Q, I will be making 1 by 2 A minus A transpose. Q is 1 by 2 into A minus A transpose. From this, okay. Now what I will be doing? P has been found, Q has been found. There is a method after calculating these. You can add P and Q. What you can do? You can add this P and this Q. When you will be adding this P and Q, you will be getting this matrix. If you are getting this, that means your solution is perfectly correct. This P and this Q. If P plus Q is equal to the original matrix, your answer is absolutely correct. Q transpose is this, P transpose is equal to P, and Q transpose is equal to minus Q. That means here it is, P plus Q is equal to A. So therefore, P is a symmetric matrix and Q is a symmetric matrix. This is the confirmation that P plus Q is equal to A. Your matrix, that means today, your determinant matrix 1, matrix 2 is over from my side. Any question from any one of you?
Sir, we will read this lecture with ourselves. If we have any question, we will ask you in WhatsApp group if you
No,
agree.
I'm not. No. Not in the WhatsApp group. You can ask me in the next session.
Okay, sir.
That will be better. Okay. So can we conclude today's session? So I'm concluding today's session. Solve the problems, read your content, and if you have any problem, let me know. We will definitely discuss it in the next session, and I will try to provide you the solution for that. Okay? Bye bye from my side.
Have a good time, sir. Thank you.